Hey everybody, I wanted to say thank you for being interested in my fully editable periodic table, which is available through Google Sheets. Just wanted to show you guys a few things about it, talk about it a little bit, how I use it, and then show you kind of the new addition I put at the end here. So the first thing you'll notice is that when you open it up, it is a little bit too big for the screen. So we'll have to change the size here in a second. But I did want to show you that everything in here is 100% editable. You could change this. You can change sodium, the symbol, the word, the numbers, the atomic number. It's 100% editable. Recent change here I put in, you can alter the key as well. You can change that through the drawing feature here. So how I use this first tab, the black and white tab, is I will actually have this printed out for students so that they can color coordinate it along with this tab right here, which is the families. Again, let me make this a little bit more size appropriate. So I just kind of size it down a little bit here for the screen. I will have students, I will print this off for students, they'll put it in their notes and they can color it any color that they want as long as it matches with the proper series there. So I'll show you that you can very easily print this off. Here's the print view version. This is kind of a full sheet if you want to do a full size paper with landscape. For our notebooks, they're a little bit smaller, so I usually print them off in the portrait size, which does like a half sheet of paper here, and these will cut out and fit very well inside of notebooks. But if students have issues seeing them because it makes everything a little bit small, you can do full size sheets here as well. So very easy to print, ready to go. I also, in the next tab here, I have the blank version. This is just in case you want to play any type of games. Maybe you could turn this into a game board or something like that and associate it with the periodic table. I like to do this type of stuff just because this is a physical science class that I teach. If you teach chemistry, maybe some of this stuff doesn't apply. But so here I've just got the blank board. I've also got the families. They're color coordinated, and then the families with the key. I've used that for different purposes before. One thing that I don't teach, but I did decide to put it in here, I've talked about it a little bit with my students, but I don't go into the orbitals, but I have it set up here so that the orbital blocks are shown. Notice that I moved helium over to kind of be with the S block, and I just kind of made it block together like that. Again, color coordinated. You can change the colors as you see fit, and any of the key up here you can also change. I've also got something, now this one I use quite a bit. This is, I put it in here so it's something I call find the elements. And what I do is I have this associated with Google Forms that I will give in the form of bell ringers, which I also have available. So I have screenshotted all of the different families and put them together in one image. And I will have the students come in. I will have their bell ringer ready to go on Google Classroom. And it's just very simple. They go into their periodic table and they have to find the element name and symbol that matches up with the atomic number. And it kind of lets them get to know those groups just a little bit. What's in the nonmetals, what's in the alkali metals and actinoid series and things like that. So this one I use quite a bit. The next one that I also use is when we talk about ionic bonding, and I've got the periodic table set up so that they can very easily see color coordinated the different charges that are going to be associated with ionic bonds. Your group 1s, your positive 2s for group 2, and so on. And then also I've got the groups that either have a zero charge or don't really like to play a part in this game. And you can change that if you like to turn these into ions. And then I've also got, for the transition metals, I don't have them specified, but I just say charges may vary, and we talk about those on a specific basis when we use them. So again, this is part of the reason why I made this periodic table, is because I know sometimes charges can be made here, charges change here, And the other reason that I really made it was because of this right here, with the different families and some of the newer elements that have recently been added and changed here. I found online a lot of different places where these were either part of the noble gases, or maybe they weren't. Maybe they were part of the transition metals, maybe they weren't. And I couldn't find 100% information on that. So I just made this editable, and as it changes, you can change it. Then the last thing I added, now this is the newest part. This is pretty cool. This is my calculator. Okay, let me change the size here just a little bit, make it a little bit bigger. And what I've done here is I made a calculator that works on charge, it works on mass, and it will also show what element we're dealing with here, and it gives us a key to talk about what family it belongs to and a bunch of information. So I'll give a little bit of instructions here. It just says change the number of protons, neutrons, and electrons. As you change the values, you will see the information below change accordingly. Okay, so right now we have it zeroed out. There's no element with atomic number 0, so there's nothing there. So as we change this, I've got these as drop downs. So 2 ways you can do this. You can just hit the drop down and you can say, okay, we're going to go with 1 proton. Okay, you can see what that did. It changed every place where we have protons here. And it says for our charge, we've got a +1 because it has 1 proton and no electrons. Mass calculator says it's a mass number of 1 because it's 1 proton and no neutrons rather. And then this is directly modeled after our periodic table. So this green for the nonmetal here, and it is number 1 hydrogen, or H hydrogen, and then the atomic mass that we have here. I'm sorry, atomic weight. So you can change this. Let's say we do when we want to make it a hydrogen 2. So we can add 1 neutron. So mass number is now going to be 2. It doesn't change this just because this is directly from our periodic table. This is how you would find it. It's still a nonmetal, that doesn't change. But what it does change is it changes our mass number to hydrogen 2. Atomic number is still 1, mass number is 2, and we still have a +1 charge. Okay, let's go ahead and add in our electron, and we'll try to neutralize this charge. Add in our 1 electron, and you can see our charge neutralizes. We've got 1 proton, 1 neutron, and 1 electron, and this is what it looks like. Another way that you can do this very quickly is that instead of, let's say, opening this up and scrolling all the way down and finding, whatever number, and sometimes these get out of order. I'm not sure 100% why this happens, but so to mitigate this, easy way to do it, let's say we want to talk about uranium. Just double click it and then type in 92, enter, and boom, here's our uranium. And obviously it's got a +91 charge, which doesn't really exist because we've only given it 1 electron. So you can iron that out if you want, and you can make that 92 electrons. We got a 0 charge, and then we can make this not what I wanted to do. And then we can give this a bunch more neutrons as needed. Okay, so you can do this and you can bounce around the periodic table and kind of see what does it give me. Let's try 101, which should be mendelevium. And you can see we get mendelevium. We can try for sodium, and we get sodium and the associated group. So again, there's a bunch of different ways you could use this to help students kind of identify with what they've got, and maybe they can turn it into a guessing game. So just wanted to show you guys that. Again, thank you so much for being interested in this product. I'm sure there's a bunch of different ways that you could find to utilize it that I haven't even thought of yet. So thank you very much.